Linear algebra is a good idea to first denote something you learn in algebra 2, because we're going to convert that into linear algebra, which makes things so much easier. It's beyond belief how hard we did things in algebra 2, where one example of it is y plus z. You must know this one: 6x plus 2, y plus I don't know, 5c equal 2. So, and then sometimes it's not consistent. X plus 2y plus z equal 1. So that looks confusing. We won't start with that. We'll start with a two-dimensional thing like this: 2x plus 1 half y or something equal to 2. And then we can make that into a matrix in the software. We used to do substitution, which is very complicated usually. This one's actually pretty nice. 2x plus a half x equal 2. But any any um, any of you guys did this in middle school, high school knows the complicated version of these, and they don't want to do it. Um, yeah. And then the way we do it is 1, 1, 0, 2, 0.5, 2, and then we just play around with the numbers where we do 1, 1, 0. So we have a pivot point, which we'll talk more about later, but we're trying to simplify it. We're trying to show pivot point means it's just definition. Like this is a column pivot point and this is a row pivot point. It's just definitions about basically saying that there's a one in a place that is a specific place in a row echelon form, which is a fancy way of saying I like the ones that in the middle and the sides like this. And if you get bigger, I love the zeros there, like this. Yeah, this is row echelon, complete row echelon form. The incomplete one can have 4, 3, 2, 1, and then 5, 6, 7, 8, 9, and then 0, 0, 0, 0, 0. Because if you have this, and we'll talk about that sooner or later, as we dive into my notes. Because I want to make sure I know what the shit I'm talking about. So, the one thing you need to know about linear algebra is that we don't like to use these variables anymore. We like to say x1 plus x2 x3 equal 10. We like to say 6x1 plus 2x2. I don't understand why don't they teach this in middle school or high school, because it'll make it so much better. 3, and then so on. Uh, and then we know that the x has to equal the same thing, and shenanigans like that will ensue. Yeah, and then we need to note that ax equal b and ax equal 0 because they're both special. Uh, we'll talk about that more when I define things more. But for now, we're going to go with this, which is 2. And then we can actually multiply this by 2 and to get 1 over here very easily. And if we want to, we can shift this to 4, 1, 2 for some reason. I don't know why it will do this, but it's fine. It will still give you x1 and x2 somehow. Yeah, even though it's more complicated now, you can still get 4, 4, 4 minus minus, and then do shenanigans like this, which will give you 0, -3, and then 2. How I did that. Um, so this is the bottom row, so I multiply this by 4 to get this, and then -1 to get a negative version of it. And then I said, okay, so I have at least if I add this to here, I get 0. If I add this to here, so 4 minus 4 equals 0. 1 minus 4 equal -3, and then so on. Now, I need to define augmented matrices actually. Um, when I converted this to this form, I actually had a line over here that said that's an augmented matrix now, which is fine for our context. We don't need this anymore. Oh, wait. Oh, I made a mistake here. Oh, shit. This is supposed to be 4. 4. So this is actually 4, and this is actually 4. Oh well. It doesn't matter. I made that equation of right now, so it really wouldn't matter. But, for accuracy. 4, -4. Oh, no, it'll be positive 4. Great. Now we have pivot points over here and over here, like I talked about. So if you really wanted to do it, I could say x2 equals 4 divided by 3 negative, which I think we got the same thing, but I messed up with the, yeah, so, and then over here, we could say we could plug into over here and then get it. Or if you want to be more fancy, which you don't need to. Did I get this one right? Yeah, so -3, and I can do 0, 12, and then what is this? Minus, I don't know. So it's plus 8, so it's like 8 divided by 12 if I do x1. Well, and then that equals something like 4. Oh my god. My brain! The 2 divided by 3. Okay, great. Very awful. Yeah. I think I need to clear this board. I was going to use that, but who knows? So we need to know basic definitions. So how to multiply matrices is usually taught later, but I say, what's the point of teaching you later when it would be helpful to know AX equal B with the idea of this. So if I had X1, X2, note that x1 and x2 is like the same thing in algebra as x2 equal y, and then that. Note that, okay? Because you're going to get confused really heavily if you don't understand that concept really fast in your understanding of this content. So A1, A1, 2. So you can do 11. It doesn't really matter on the first one unless you go to the second row, which is 2, 1. I'm doing definitions right now. A 3, 1, A 3, 2. So when we do multiplication on matrices, you need to note that this is 2 and this is 2 by 1. So 2 by 2, and it's not multiplication. The note is not multiplication, which is kind of confusing, but it is not multiplication. It's a matrix that you would denote by a letter of A, B, C, D, E, whatever. And then we have one matrix here, and let's just say that the other matrix is 2 by 1. So what we know, that's M and N. Basically, that is what's called M and N. So if you have 2 M and N, which we have here, these two can only be multiplied if these two are the same. M has to equal M, which is kind of confusing because they're the same letters I'm denoting. But the nasty trick to use is that the close inner people die. Yep, inner people die, and you get the outer, and then and then you make a new matrix because of that. And now we know that this and this will create a 3 by 1 matrix over here, which is considered B. Now, what's the point of the shenanigans I'm talking about? What's the point? What's the why? Well, what we just said is basically AX equal B, which let's go back to the idea of a system we have. A system of 1, 2, 3, 4, let's just say, and then 1, 2. So actually, the 1 and 2 will be considered B, and a very interesting B. So that is AX equal B. So what are we trying to find when we have this? So actually, 1, 3, 4, 2 is considered A. So then x equals, so this is x. And if we notice it's by a 2 by 2 and a 2 by 1. Now that gives us a special power. Well, it gives us, if I had three equations with two variables, I can multiply that by, so kind of x1 and x2 to give me a v. Ultimately, I can do multiple equations at once. Well, then can we do three equations? And yes, we can. And then this would be expanded to one more. So that's how we process that. So I'm too tired to actually write this carefully, so I'm not going to do the A11 shenanigans. Um, and then I made a mistake because of that. Well, we'll have to clear that flame and do this again. A11, A12, A113. Wait, I did it wrong. There's no one here. Anyways, how about if we have 2, 1, 2, 2, and then another one, and so on. So over here, but it's a 2 by 3, and there should be now a 3 by 1. Now, this is gonna be tricky, right? Because can we solve for all x, x2, x3? The answer is no. But that's for another. That's a little bit later. But right now we're gonna talk about if I do it like this. I'm doing denotation right now, honestly. So a 3 1, the denotation like this. This is 1 3. So that's denotation. That's a quick way of saying that. And then we have x1, x2, x3. So this is what your teacher is saying when they're doing confusing algebra shenanigans, and then B. Yep, that's what they're saying. Now you can kind of see that so does that mean that I can solve for all x2, x3, x? No, definitely not, because of something that uh, we'll need to touch on: free variables and no solution and infinity solution. Infinite. Not likely to have infinity in here, but just good to know. So if I have 2, 4, 6, what else do I need? That's good enough for infinity. If I have this and let's just say I want b equals 1, 2, well, if I look at this carefully, 1, 2, this is 1, 2, 3. Oh, I accidentally created infinite solution. So that's infinite solution here because I meant to do no solution, but I accidentally created infinite solution by accident. A key, my brain didn't work quickly. So if I were to subtract this into the other section over here, this one, by 2, 4, 6, 2, because it's easier, I can get 0, 0, 0, 0, which means there's a free variable, and the free variable just means that x2, x3 can be anything. And this notion really means a variable from negative infinity to infinity, if I remember correctly, which is a pain in the ass later on, because R also means a bunch of other things like a field and onto and one-to-one shenanigans, whatever. Anyways, what time is it? How long have I been talking? 14 minutes. Okay, that is not much. Key. So, alright. So I refuse. Alright. So I think it's finally time for me to try and do, um, you know, the a low reduction right now with, I don't know, a made of three, and we'll see how that turns out. I mean, we can go for the classic. No way. Yep. We can go for the classic this if you want. And there's I don't I hate writing this echelon form and reduced echelon form. Pain in the ass, not pain in the ass. That's basically what these two are. One, painful, non-painful, and this is a pain in the ass to deal with. That's all you need to. I mean, there's a lot of things to know about them, but yeah, that's what I call them. So, uh, actually, did I ever show? Okay, what's the easy one? I don't know. Yeah, this is gonna be pain mass. Low reduction. Fine, I have to get over it. 2, 4, it's just a random 6, odd number 3, 1, 4. There's no way this is gonna be infinite. Oh, another thing to note, if there's zero, oh, I forgot to show about no solution. Damn it. Okay, I'll talk about that right now. No solutions. Basically, if I have 3, 1, 2, 3, and then there's 0, and then 1, basically this turns to 0, right? But there's still 1 left, which means 0 cannot equal 1, although, therefore, that's invalid equation right there. I'll be using 1, 2, 3 a lot because that's the simplest things to write. So why not use the simplest thing to write to make something, right? And then like 1, 2, 3. I'm such a lazy person. So we have this. We always start from on the top. We'll start with the easiest. So we'll actually rotate this around because there's 1 over here, which means we get an instant pivot point without actually working for it. Um, which just helps a lot. And once you denote the pivot point, you should not move that around. And then we have 2, 4, 1, 1. So I'll be multiplying a 1 to 3 by 6, 12, 18, and then 18 again. And then that would be minus, 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 minus. That's just nothing. And then that would be outside of my link because I don't want it in my matrix actually. So 1, 0, what's that? -9, -9, -14, a pain in the ass, I said, -16. But less pain in the ass than doing substitution, which is the old way of doing it in Algebra 2. You remember those? They were a bunch of pains in the butt, if I remember correctly. You see how we're getting rid of it by one letter at a time. Reduction, you can easily make a mistake on. Definitely true. So we're gonna now do the 2 ones, so -2, -2, -4, sorry. Why we're sorry for that. 6 negative. So I have 0, shit, okay, 0. Oh, we have 0 over here, which is perfect. That gives you a great form, which is -5. And then we have what's this? -5 again. Oh wait, we have up here we can divide by 5, -5, -5 over here, which equals x3 equals 1. Now I can continue doing this to reduce rational form, but that's a pain in the ass. I don't like that. So I'm a lazy cunt, and then I say, okay, so this equals each other. Alright. So I have -9, -14, -16, and 3, 3, 2. Well, I can plug into here, so I can just do -9 minus 14 equals -16, and then I can just do x2, and then you get the point. But that's just a lazy way math of doing it. I would recommend you do low echelon form because there's some tricks about it and there's something special about it later on that we will be discussing. If it hasn't been 20 minutes yet. And it hasn't technically been 20 minutes, so we're gonna keep on going. Okay, so we're gonna talk about, I guess, echelon more because I am blind and I think I missed a lot. Well, if I missed something, I will talk about it later, probably eons later. But yeah, I will talk about it later. Um, Actually, I have a class tomorrow. Shoot. Um, I need to do that homework too, called physics. I'll be start doing that tomorrow, I guess, and studying for the Friday test. Uh, Over here, we're gonna I'll go fast here. So over here, let's just say there's a number over here, one, because we're gonna teach about a number. So this is echelon form. So four can be there, three can be there, and then you can have random numbers. This denotes random numbers uh, in algebra two. No, sorry, in this class. What's this class called again? Uh, uh, that's linear algebra. Hmm. And then you can keep on going like that. And then you can see a ladder. But trick is you can't have two ladders. You can't have two like this. No, two like uh, one and then like three and then do something like that. That's illegal. Like you have zero over here and then one over here. You can have two breakers, but that's pretty much it. You'll see why later on if you do a lot of problems that everything can be turned into like shifting it. If there's something like this and there's one over here, uh, something's wrong. You did something wrong. You can shift this around and do something to get it to echelon form. Um, Another thing to note is if this is 0, 0, 0, 0, 0, you have something called leading numbers like 1, right? And this is considered reduced because there's 1 is a front runner. And if I do this is fine, if I do this is fine, and then having, I don't know, like this over here, this is a bunch of these, and then 1 somewhere. Another thing to note, a 0, which is a which is I got wrong in the test, is considered both reduce and regular echelon form, which yeah, pain in the ass. I got that wrong on the test. Yep. Uh, and the periodic description is later. Great. We'll talk about that later. I need to study for physics now. Okay, we're gonna stop this video.